Good evening, everyone. A warm welcome to all of you from Center for Science and Environment. The theme for today's webinar is targeted at wind energy developers to discuss the issues and concerns revolving around repowering with specific reference to the state of Tamil Nadu. As part of the 2022 draft policy, developers are required to meet certain conditions in order to repower their old wind turbines. In today's webinar, we'll focus on the challenges that developers are still faced with, that is, identifying the potential turbines for repowering, obtaining the project size and transmission capacity, selection process of the developer by a wind repowering project aggregator, licensing issues with the utilities and the utility woes on additional wind power purchase, among other concerns. Center for Science and Environment is one of India's leading environmental research, advocacy, and capacity building organizations. Our renewable energy program has been working extensively to help shape the policies at national and the local government level that lead to deployment of renewable energy technologies, build public awareness to strengthen the energy access, and to facilitate optimum use of the natural resources. Harnessing the potential of wind energy is proving to be difficult due to its intermittent nature and the limited number of favorable sites. However, wind is being increasingly used to generate electricity and its application is likely to go up in the future. India's wind power sector has been exploring the possibility of repowering the old wind farms, which can accelerate the capacity addition. In August 2016, the Ministry of New and Renewable Energy released its policy on wind repowering. However, a right to information query addressed to the Indian Renewable Energy Development Agency, IREDA, a government body entrusted with financing repowering projects, has revealed that not a single project has availed an additional interest rate rebate for wind repowering under the Repowering of Wind Power Project 2016 between the years 2016 and 2021. For the past few months, my colleague Bineet had been working on the issues pertaining to repowering in the state of Tamil Nadu. He has interacted with various stakeholders to deep dive into the challenges faced by the developers. He has come up with a consolidated report that addresses the various issues, which is now available on the CSC website. A brief presentation of the conclusions of the report will be shared by him now. Over to you, Bineet.
Thank you, Maitri, for that brief introductions about our the Center of Science and Environment and about the program that we are working on. So I'll be quickly sharing my screen and I'll start the presentations. Please let me know if it is visible.
Yes, it is.
Yes, it is visible, right? Okay.
Yes.
Yeah. So the world currently is confronted with pressing energy-related concerns, while fossil fuel combustion is adversely affecting the environment in today's context. So a report reveals that since the year 2000, the demand for primary energy across the globe has increased at an average rate of 3.7% per year, with the world populations projected to increase up to 10 billion by 2050. So coupled with raising living standard, meeting energy demand would be a major challenge going forward. So harnessing the potentials of wind energy for the grid applications is proving to be a difficult because of its intermittent in nature and the limited number of favorable sites across the globe, or if we call it as across India. So however, wind is being increasingly used to generate electricity and its applications is likely to increase in the future. But if we look if we try to see closely in the right side, right graph, India has added only a small wind power capacity about 1.5 gigawatt annually over the past 5 years. Uh, and we can share the wind power in India's total installed capacity of entire India is only 10%. With the total power generations at 1400 billion units, India accounted for just 5% of electricity generations. India ranked fourth in the world in terms of installed capacity of wind power, which is a capacity close to 43 gigawatt. Tamil Nadu and Gujarat, if we see in this graph, have 25% to 22% of its capacity in their respective share. If we see the National Institute of Wind Energy's estimate, the country has a potential of 302 gigawatt at a hub height of 100 meter and close to 700 gigawatt at a hub height of 120 meter above the ground level. Most of these potentials, wind potentials, are exist in the 7 windy states. Those are Rajasthan, Gujarat, Madhya Pradesh, Maharashtra, Karnataka, Andhra Pradesh, and Tamil Nadu. So Tamil Nadu has only been able to tap 14% of its potential. So if we see the potentials and the installed capacity currently, it's 14%, and whereas Gujarat could only utilize around 7% of its potential. So wind resources are very site specific, we all know. According to NIWE's estimate, the exploitable or wind potentials that we can generate, we can install is 800 gigawatt at a 100 to 120 meter height that have been discussed in the last slide. But the best class 1 sites which with a high wind speeds and high wind power densities have already been exhausted during 1.5 decades of sector's development since 1990s. So and in the plant load factors, the PLF of old wind turbines populating these sites are very low at 10 to 15%, which is compared to more than 30% achievable by modern wind turbines. If we repower these old turbines with a class 1 turbines, this capacity can be increased by 2 to 3 times. The PLF can also, we can increase the plant loading factors, we can increase the annual energy productions as well. So at present, 9.9 gigawatt, Tamil Nadu has the highest installed capacity in the country, which is 1/4 of total installed capacity in the country. So with the best wind sites in India, aided by favorable policies by the state government and low off-taker risk, Tamil Nadu is one of the earliest states to initiate such wind projects. However, most of these projects are still operating with turbines that runs on old technologies that have low hub height and low capacities. So approximately 3,000 turbines, 3,000 such turbines are still there, and with a lesser than 1 megawatt capacities. So cumulatively, if we see those many capacities would be around 800 megawatt. So they have already completed their design life. Therefore, Tamil Nadu is the ideal place to take the lead and to repower the older turbines. So why repowering is not taking off? So if we see these 8 points, we can clearly explain that there is a tremendous growth of wind energy in the Tamil Nadu has been driven by sales tax benefit, accelerated depreciation introduced in the state since 1992. So consequently, the state has attracted sizable private investment supported by turnkey suppliers. So each private players own one or few windmills, and these are very fragmented in nature, and their ownership is fragmented. So this fragmented ownership means that there need to be there need to be a distance between two projects, two turbines. And within the project, there has to be a distance between the turbines as well. So if we consider such kind of a problem, and we have seen that earlier attempt at repowering have failed in Tamil Nadu and Gujarat because of this fragmented ownership issue. The electricity rules in 2005 of the Indian Power Ministry state that to qualify as a captive generator, a consumer must own at least 26% of equity stake in the generating company, and it shall consume at least 51% of the aggregate generations. So with such rules in place, it is, if a captive power generator seeks to opt for repowering, then the aggregate generations might increase up to 3 times. So they have a probability to lose their captive status. Next is in Tamil Nadu, most of the wind farms are connected to 11 kV lines for the evacuations of power. However, post repowering, the capacity and the aggregate generations may increase by 2 to 3 times respectively. Hence, there is a need to upgrade the existing infrastructure such that all the energy that being generated by can be evacuated properly without any congestions. So there is a infrastructural challenges as well. So in November 2018, government of Tamil Nadu, with a tangent proceedings, they have waived off or relaxed the 7D, 5D spacing criteria to 3D, 5D criteria. But however, in some of the areas in Mupandal and Pulamvadi, this criteria is still inefficient, and ever since have like new habitats has came up in those areas. The cost components obviously should be considered for valuations of the existing wind projects. As of now, there is no benchmark cost that has been set for these components in India. We have seen the owners of wind turbines that they have completed their life but continue to be operational even at a very low plant loading factors. They are not willing to go away with their assets. These wind projects have already provided them ample returns on investment, and owners continue to earn without any initiative to repower. There is a issue of dismantling the old assets and installations of the new ones because it's required a minimum time to complete. So this entitles a loss of generations during the construction period and could be an issue for the wind turbine owners. In the last 15 years, several households and dwellings have mushroomed in these wind farms, within these wind farms. So owing to this factor, transportations of larger turbines and longer blades through bends, narrow passages are very difficult to move within those old sites. There are few recommendations that I have accumulated across keeping all the challenges into considerations. Though those recommendations, there can be more recommendations. We have our expert panelists in today's webinar. So I'll just quickly run through this slide. Firstly, it is mandatory to conduct a safety and performance assessment of all the turbines that are connected to the grid and that have been in operations for more than 20 years. Next is replacement repowering can be an options, like a simple replacement of old turbines with a newer ones of the same capacity will not only improve the CUF but also results in lower generation losses due to cutoff phenomena in class 1 and class 2 sites as compared to megawatt scale turbines. Under the wind park and wind solar hybrid development schemes, the government can identify those few tranches of repowering and could develop enhanced transmission infrastructure as well. In Maharashtra and Karnataka, we have seen the power purchase agreements are limited to 13 years. So hence it is possible to take up repowering early in the early in the life cycle of the projects without impacting the contract and adding much complexities. Next is we can create a group of companies, for example, Ramco, TVS, or Chettinad Cement in Tamil Nadu, which can be a viable options. This will help replace their old turbines and with the newer ones, and they can establish the confidence in their sector. In order to address the challenges of transportations through these dense pocket, uh, a direct drive wind turbines that is gearless of at least 1 megawatt would be a better solutions, since we are not we will not only get the smaller size and the weight lesser, but the efficiency is also going to be a increase. This will eliminate the gearbox failure kind of a arrangement. This is a tentative suggestions from our side, but yes, the expert can take the decisions on a further note. Considering the complexities and the challenges involved in repowering development in India, OEM or original equipment manufacturer driven business model can be initiated in the sector. And state must facilitate easy terminations of power purchase agreement. State government must support them without accruing any penalties for the developers. So I'll be sharing case studies, and then I'll close this presentations. That will be my end. Before that, I would like to explain this slide a bit in a critical way, because we have got two observations out of this. So Vasanguri wind park is located in a mountain plateau of around in a Koyna reservoir in the Maharashtra state, which is 40 kilometers from the Satara town or Satara district. So wind power has been generating from Suzlon turbines of 350 kilowatt each, so resulting a total power output of 243 megawatt. So this study was to identify the repowering potential by the wind park and was carried out by USAID in 2022. So various technical parameters like turbines, parameters of turbines like rotor turbulence, fatigue spectrums, machine designs, input data like site details, climatic conditions, those has been taken care of very critically. Additionally, evacuations limitations and the availability of land, excluding the orientations of land and contour, were examined well in this case study. So 4 micro-siting layout combinations was there: 3D, 5D, 4D, 5D, 6D, 5D, and 7D, 5D, were situated to see the differences in energy yield, CUF, wake loss, and energy yield ratio. So for each arrangement, the total energy output from the machines were calculated considering all the losses such as wake loss, turbine availability loss, and grid availability losses. It is important to note that higher wind power can be generated from the same land parcel in the 4 layout combinations that it is shown in this table. We can see that the capacity of repowered layout keeps on increasing. Also, there is a compact arrangement of turbines and with less spacing in between. Compact arrangement with less spaces in between. The CUF decreases with sparsely placed turbines. There is a decrease in the wake loss. So we can conclude from the above table that there is a slight decrease in CUF of approximately 2% at 3D and 5D, but the energy yield ratio increases by 2 times. So the same thing has been replicated here in the graph. So after the comparative analysis based on the 3 categories of repowering, it can be observed that capacity additions and energy generations will ensure maximum land usage. And maximum energy generations, which is megawatt hour per square kilometer, will ensure maximum resource utilizations of old site, which is the main aim of repowering. So with this, I would like to end the presentations, and I'll hand over the floor to our moderator, Ms. Maitri.
Thank you, Binny, for sharing with us such an insightful presentation. For today's webinar, we have brought together an interesting panel. Let me introduce them to you. So we have with us Mr. Jaykumaran Surya, who is the Chief Executive Officer of Vailo Energy Private Limited. And we have with us Mr. Karunamurthy Neetimani, who is the Managing Director of WinPlus Private Limited. So we'll start today's webinar session with Mr. Jaykumaran Surya, Chief Executive Officer of Vailo Energy Private Limited. He has about 30 years of experience in the wind energy sector. Vailo Energy Private Limited has 3 decades of successful experience in generating renewable energy. It's an independent service provider for wind turbines and provides flexible solutions to latest technological challenges, acting as bundle service for business. So I would now like to invite Mr. Jaykumaran Surya to give his opinion on the challenges faced by the developers in Tamil Nadu in the wind repowering sector. Over to you, sir.
Thank you, Maitri and Binit, for the wonderful introduction and the brief about the repowering concerns in Tamil Nadu. So I'll just take through some points for the wind and non-wind guys, so that they will understand from the basics. So how this transformation happens. Could you able to see?
Yeah.
Is it okay now?
Yeah.
Yes, sir.
Okay. So myself, Jaykumaran, I'm the CEO of Vailo Energy Private Limited. So the caption what we keep even in our company is strive green energy and survive tomorrow. So unless you don't strive green energy, you cannot survive. So the basic caption is, so how this is for especially this non-wind audience who are all in this call. Like what are all the renewable energy sources? Like wind onshore, wind offshore, solar photovoltaic, and solar thermal, hydro, which is small in capacity now, which is not taken up in a big way. Marine, that is tidal, and marine wave energy converter. Wave energy converter, it's getting matured, which is the only one which gives 24 hours power supply. It's better than wind and solar, which I would recommend going forward for the country. Like as we are having all 3 sites coast with high tides, so which will give 24 hours power. I think we can fulfill our country demand. So the wave energy converter, it's getting matured in the European market, and even in the USA now they started promoting this. China and Japan is also getting into this. So for sure, in the coming decade, wave energy converter will have a great contribution. Then the geothermal, still we have a lot of concerns in taking the geothermal energy. Biomass, biogas liquid form, and biogas solid biofuel. In this also now the maturity is happening. So for sure that in the next decade that biogas, as this farming industry is booming up in our country, so this biomass and biogas definitely will take a lead in the coming decade. So for next generation, for sure, on above all this, we can make some mixed above plants, and we can make hybrid concepts. We can make the hydrogen from the renewable energy, which is being called as green hydrogen. There are other sources of hydrogen being made, but with renewable, when you make, which is being called as green hydrogen. Then later into energy storage system. So later now this country, every instruction being given by the central government and the state government, you become the self-sustained. Means like at your home also, you create the renewable energy with wind or solar and make yourself sustained by keeping this in your premises. The same thing would happen in the future in a big way, for which we need to make the energy storage system around our substation and create the industrial sectors like SIPCOT or SIPCO and small industries, which will consume the power. So the demand which is being created by the local can be consumed, so that the hybrid concept can be made now. So today that concept is not being especially made through. Why? Because this local demand fulfillment is not happening by the consumers. So this hybrid will take lead in coming years for sure, as our Make in India concept, MSME, promotes lot of local, entrepreneurs. So for sure, they will make use of this. I think this is taken by Binit. I just take through. The global wind energy capacity in 2022, almost it is 900, it's hitting. Whereas in India, we got only 43 gigawatts, hardly 5%. So last 5 years growth, what Binit has also said that we are not ramping up in a big way. But for sure, once this offshore, I think in coming years, when it comes, this onshore and offshore put together, make good rapid growth in our country too. And this is the energy mix of India, like how much the coal and how much diesel, nuclear, gas, hydro, and renewables. So if you really see this, still this thermal coal lignite contribution is more, and renewables follow second. And going forward in by 2030, for sure we'll hit put solar and wind together 300 gigawatt plus. So for sure that will happen by this government, and all the state contributors lead. And this is the renewable energy mix of India, which we have. Waste to energy 495, small hydro 4,900, bioenergy 10,213, wind energy 4,166. Now, what Binit said, it is 43 gigawatts. So additional, which happened in last couple of months, which created, but still this solar, which you really see, the pace which they have taken up. So it is going very, very good in across all the states in India, because wind has got restriction in 8 states. Like we can put only the windy states in western part of India, as Earth rotates in the anti-clockwise in this orbit near the equator. So we have Rajasthan, Gujarat, Maharashtra, MP, Karnataka, AP, Telangana, and Tamil Nadu. These are all the windy states. Northeast, yes, still they look lot of opportunities, but for sure that going forward, the class 5, class 6 wind comes, wind turbines technology comes with a hybrid concept of solar. I think for sure we can make Northeast also workable. Now the solar is doing very well there in those states. And this again explained by Binit, like we have a good potential at 100 meter and 120 meter. These are all the class 3, class 4 sites. Class 1, we can go maximum up to 60 to 70 meters. Class 2, 80 meters. Class 3, 100 meters. Class 4, 20. And now we are going up to 140 meter also, which may be increasing in coming days by 150 or 160 meters. And these are all the state-wise installed capacity. Tamil Nadu and Gujarat takes the lead in India, both almost hitting 10 gigawatts. Gujarat will, overtake Tamil Nadu by this year for sure, as Tamil Nadu is not making much wind projects for last couple of years. And Karnataka is having a plan of 4,000 megawatt in coming 2-3 years. And what we want to see is the topic today is the fit for repowering. How much repowering which we could make immediately, like, so the central government has given 2 kind of directions. Initially, they gave direction of less than 1 megawatt. Then they give direction of less than 2 megawatt. But really, if you see, we need to see the PPA, which is having already workable by the state governments. Tamil Nadu is giving 25 years. Rest all states give 20 years, except Maharashtra. Maharashtra gives only 13 years of PPA, which got over. So thereby now Maharashtra growth is also getting down. And now they are working some new concept of hybrid. I think the tariff would go up so that they will get into business. So the major contribution in the repowering, if you really see, Tamil Nadu, Maharashtra, Gujarat, these 3 states and next Rajasthan, we have the potential. And Tamil Nadu for sure, as Binit said, that we started almost 4 decades ago, and the pilot projects which got installed in Tamil Nadu and Gujarat. So where Tamil Nadu took a lot of leader initiatives, whereby we call Tamil Nadu as the birth of wind in India. So where the promotion is very fast. Now the potential due to this repowering, if you really see, like we have a lot of fragmented issues, like one feeder has got different clients. So like 11 kV, 33 kV, we need to find the group of clients wherein we need to form a consortium so they can put the complete acceptance for creating this repowering. or else this repowering creation would be very, very difficult. The concept, yes, we will discuss a lot, but practically the implementation will have a lot of challenges. But still, I have some suggestions and conclusion which we'll take through. These are all the 4 passes we call it as in Tamil Nadu: Sengotai Pass, Arlovamuli Pass, Palkad Pass, Kambam. Kambam, it's near Theni. So this all 4 passes create a funnel of wind, wherein these wind farms are developed. Average wind speed is 6 to 8 meters per second. And now we are getting into class 4, whereas the wind speed is up to 6 meters per second. So the repowering is possible in 3 passes area, that is Arlovamuli, Sengotai, and Palkad. Kambam, it's having turbulent wind and it has got only the megawatt and which got developed very recently. So thereby this repowering concept, these 3 passes will have. Physically, you can see how these passes are made. On the Western Ghat, left side you can see from the Kerala, when Earth rotates anti-clockwise, the wind being pulled towards the Western Ghat and it becomes a funnel towards the land. That's from Arlovamuli, Sengotai, Kambam, and Palkad, whereby the windmills are getting promoted and developed. Now, at the down south, if you really see this Arlovamuli, it goes up to Ramnad now, including the Sengotai Pass, both put together. So it is almost contributing 70% of the windmill installation in Tamil Nadu. And Palkad and Kambam, both put together, Theni, Darapuram, Coimbatore region, Tirupur region, they contribute balance 30 to 40%. So the major repowering possibility is in Arlovamuli and Sengotai Pass, and some in Palkad. And if you really see this Weeble parameter, so the Arlovamuli Pass is having a very good wind potential, followed by Sengotai Pass, Palkad, and Kambam. So if you really see this repowering, we need to focus mainly on Arlovamuli, Sengotai first, later into Palkad and Kambam, so that the investors who want to put in this repowering can yield better. And what is repowering? Repowering is replacing the old WTGs by more powerful and efficient models that use of latest technology. So that is the basic requirement. And what are all the benefits for the repowering would be? Increase in generation capacity, for sure. You will get height in increase, and new models will definitely bring better generation, as we have transformed from the macro level technology into micro nano level technology now, and holding the best energy landscape, which is already readily available. So you need not to find the wind resource study, which is already studied, and we can immediately go ahead with the repowering. Cost saving from the upgradation, for sure, because we can make some use of existing infrastructure, some possible, some may not be possible, like foundation and blades, which we need to dispose, which we cannot use of. But the grid inter-network, which can be made use of, the existing poles we can strengthen up, and the conductor we can immediately change, and the transformers we can do some refurbishment, by which we can make some possible utilization of existing infrastructures, so that the cost will surely go down on repowering. Then we will have better grid integration already, which we made a lot of study with the SLDs and the national load distribution centers. So how this grid integration to be made for non-conventional, conventional, and like atomic, like what we have in Kodangulam, which is going to be 6,000 megawatt. So the corridor, it's clearly distributed in a different way to connect to the national grid. And apart from this, they made the green corridor of 765 kV line, which will connect the solar completely going forward from Tamil Nadu to Kashmir. So that will be exclusive for the solar, which they will look for. Now it is having a combination of wind and solar, but in future that will take only the solar, so that the distribution between the solar and wind will have the correlation issue can be avoided. Next, what are all the challenges? What we really look for, like the shelf life closure of existing WTGs, which will be immediately stopped. The forceful in some cases, whereby this investors and the owners will have a generation loss. Okay, that will be one challenge. Then the next challenge would be structural instability, which is almost 20-25 years which is gone. Even some of the turbines with the low, smaller rotor dia and shorter WTGs, which is 30 meter and 25 meters, which is having a structural instability, which we don't see. But yes, in some cases we get into some accidents, some fire incidents. So that refurbishment, it's not properly happening. So basically the structural instability, which creates a big challenge for existing model. And the wastage disposal, that is the sort of waste, which will be having a serious issue when we go for repowering. And government and the private sectors and a lot of people are working on the blade disposal. Either we need to form the blades into a different byproduct, or make use of this blade parts into the boards and other people. So really disposing would be very difficult. And the IIT people, they made a use of the blade powders into forming the roads, you know. And some government also taken initiative of that IIT to keep that into their projects. So they made use of this blades damaged parts, scraps. The another challenge would be the existing foundation, because the locations which we talk about, the repowering, will have very close confined landscape for the owner, wherein he will definitely look for the same capacity or combining two machines, whereas this land will not permit. So on compulsion, he needs to remove the existing foundation. So that will be also, using the dynamics and other kind of breaking challenges which will follow him. The next point would be the loss of generation, which we talked for constructing the new repowering, which will take minimum 2 years. So still we get an approval today from the government. So it will take 2 years. So the 2 years, the generation loss also a concern, wherein the investors and the existing owners have put their concern to government for giving some facilities. So this is the SWOT analysis, how the strength, weakness, opportunities, threats, which will hit our repowering. So when you see this strength, this is all existing studies internationally, and now India also done a big study, like CSE has taken a lot of lead in across India to various states, and Vineet has personally visited the wind farms in Tamil Nadu, Maharashtra. So this all informations from across globe and India will definitely strengthen, so that it would be useful for the government to easily take the due diligence faster. And it is so simple. So low upfront investment, that is also now a lot of investment plan which we are making for the repowering. For sure, this will be a strength. And what are all the opportunities which we look for? So the opportunities, all the investors which they think and get green directions from the government, or the additional incentives, lower environmental impacts, and second-hand wind turbine market. So that second-hand wind turbine, which we can definitely, instead of disposing it, we can find some countries, very remote countries, poor countries, we can move them to those countries by doing some refurbishment. For at least next 5 to 10 years, they can make use of this existing smaller capacity turbines. So that could be one way of, the government can look into this. That opportunity is also there. Then the cost reduction, which we discussed, and for sure the technology improvements from class 1, class 2, class 3, class 4. Now class 5 also now already started with megawatt series and offshore. So this technology improvement has got a vital opportunity to bring this repowering. And what are all the weakness? The lack of experience in the repowering strategy in India, especially. What I will say, Denmark and Germany, they made a good study, and they are pioneer of repowering the existing wind farms, and they do the repowering in two manners. One is the refurbishment of existing and giving some immediate extension of the turbines for next 5 years, and other aspect is removing the existing model and putting the megawatt series or the equivalent model. So that way, Denmark and Germany successfully done, followed by UK, USA, California especially, and Spain. These 3 countries also now taken very good initiative. Only these 5 countries. So this experience of the global on repowering still having a lot of anxieties, and India now getting into the topic and concept discussions. So for sure that we need to improve a lot of correction of weakness and experiences from the international market, what they gain. Then the threat, what the threats all on this repowering would be: lack of supporting incentive, which all the investors are looking for, and opposition from the other stakeholders. So even the solar and other people also will get dominated into this, and the hybrid concept will come, And some people may say that instead of repowering, they may go for some other immediate need of the local localities. So there could be different challenges which we need to work on different sites perspective. Sorry. Then the strategy not updated regularly. So the strategy which central government has given through the policies, the state government has got a different policies and different directions. So we need to make a form of proper integration committee from the IREDA and MPI to bring this cohesiveness between the central government directions and the state government. So that is also one kind of strategy thread which we look and we need to correct it. And next is the technological improvements. Some cases, yes, for the repowering immediately, which would be possible. Not like solar, wind, one model, when you want to move out of the R&D design, which will take almost 400 crores of investment. Whereas in solar, you just integrate different panels, different cables, different inverters, and you just do the project. So wind still has got that threat. And competing technologies and the experience of the people, which last 3 decades, now they got diverted into other aspects from the wind to solar and other concepts. So there be the wind real, that knowledge also getting lower. So that is also a threat which we look into. How this repowering strategy project management can be taken up. So this is the project. If you see this left side, program, strategy, vision. So EOSL, that is the end of service life of the WTG. So the repowering project planning and then the initiation. These are all the project. Then the program would be the repowering strategy implementation, which we need to look and work with utility and government and investors and all the tax and import, export. So this has got a different challenge which we need to look into. Then the third aspect would be the strategy. After having the complete study of all this, you need to make the strategy of benefiting the investors by forming a lot of government policies and the investors' benefits, banking sectors, and the power sales. So the strategy should be completely formed. Then the vision of the end of service life can be attacked as a repowering real concept, and it can be executed.
Sir, apologies to interrupt in between, but we have another speaker, so and we have paucity of time.
No, no, it's okay.
I'll take fast. So this is the same way. Left side, what you see is that existing life of the wind turbine. Right side is the complete repowering, how this repowering will be formed. So the people who are all on the call can take a photo snap or anything, that if they have any questions, like for sure they can come forward. So we'll definitely give the answers to them. So the yellow portion is going to be two kind of repowering. One is the refurbishment of the same capacity with respect to the local conditions and problems, and replacement of the turbines. And the policies, which I think I'll skip, as Binit already said, the old policies which had very few benefits. Later into last year, they got a lot of benefits, but still there is no government order released. So wind repowering committee has to be formed by the central government, MNRE, along with IREDA, with respect to all the states, which has got still need to through. So yeah, I just skip. And how this direct and indirect, regulatory and voluntary, the classification of promotion, which will definitely use of repowering. So investment focus and generation focused, price driven and quantity driven. So it could be price driven also, it could be quantity driven. So both way that we need to see with the regulatory and the voluntary of the investors. And this is the Tamil Nadu state policy, which now they say that the feed-in tariff would be 2.8 rupees, but still it is not through. And other benefits like the developers must direct and augment transmission infrastructure, whereas they look for some benefits from the government. So that is also under policy discussion. And the draft is already through. And the replacing can be three aspects, what I said, that it can be with the same capacity, which can be with multi-kilowatt of company 250 into 1,500, and 4 250 like Ramco and big clients, they can put 4 of 250 into 1 megawatt. So it could be in 3 way only. It cannot be completely removal of the wind turbine, which can replace it. That cannot happen so. And the conclusion and recommendation, which is from my end especially, forming a repower economic zone by the state government. Okay. So the state government, especially, they need to form an economic zone repower, wherein this repower will have a lot of policy benefits so that they can do this investment. Then create power trading platform, TNREC. See, in state government, there is no renewable energy certificate scheme. It is with the central government, MNRE. So if state government take a lead of power trading, which is also a concern now, power trading being handled by a lot of private agencies, but it's not getting through. The cost is varying here and there. So the government, TNREC, can make the platform to create this power trading so that the repowering investment will become more. Linking TNREC with the country REC and IEREC. Now, a lot of international agencies, they are doing that international renewable energy certificate scheme, which is started just now from Chennai and Bangalore. So this can get a link so that the power trading can happen international level also, so that the repowering will take off. Then the waiver and benefit of interstate transmission system with central transmission unit, and the state still they have a lot of discussions and disclosures they need to take care of. Then minimum 25 years PPA that must be given for the repowering so that the people will come with, I would recommend with 10 years escalation benefits. Okay. So it cannot be 5 years, at least every 10 years, they need to have some escalation benefit of the 25 years PPA so that the repowering investment will become more. Yeah. Then minimize the wheeling charges, which is very high. Minimize taxes on the repowering and component and procurements from India, also from international grounds. And also we need to find the minimize the duties through the government, central government. So the repowering component procurement could go in a better way. Then the last point, special economic zone creation at the TN state for repowering component manufacturing under Make in India benefit. Oh, sorry. Just my battery is going low. Is it okay?
Yeah.
Yeah, sorry. And because once we made this manufacturing in future for 25 years PPA, you need to have the OMS backup manufacturing setup for which they need to create some special economic zone by which the repowering manufacturers will have a confidence that, yes, we have a long-term business so that they will come forward for the investment. Then considering the onshore prevailing issues, the offshore foundation standardization should happen because any of the Tamil Nadu state government is looking for an offshore project. So there should be some standard instruction from all the OEM by the government, MNRE and the regulatory commission that the foundation of offshore should match with standard design of one tower so that any OEM nozzle and blade rotor can be interchanged. Otherwise, in future, not like ground, you cannot replace the WDGs in the offshore projects, which will have a lot of problem. Then promoting the wave energy converter in all posts by central government, which will be 24 hours possible, which I explained. So that will be also the future. So I skip other slides. Thank you. So the eminent next speaker, Mr. Karnamurthy is there. So I don't take much time. Thank you so much. Thank you all. Take care.
Thank you, sir. Thank you so much for that
Thank you, sir. Yeah.
presentation. I would like to invite Mr. Karunamurthy to take the floor further.
Yes, sir.
Let me give a brief introduction of Mr. Karnamurthy Neetimani. He is the Managing Director of Wind Plus Private Limited. He has around 27 years of experience in onshore wind power industry. He has established his expertise in independent power production, engineering, procurement and construction, project development and execution, operation and maintenance, regulatory and corporate affairs. He has worked with all the three major players, that is the OEMs, developers and IPPs of wind energy across India. I would like to invite Mr. Karnamurthy Neetimani to kindly provide his opinion on the options available with developers for repowering in Tamil Nadu. Over to you, sir.
Yeah, thank you. Good afternoon, everyone. And before me, my co-speaker has covered, from zero to hero, like he has covered from zero to hero, how this repowering, like C2C, like concept to commissioning he has covered everything. My co-speaker, Mr. Jaykumar Surya. And yes, Mr. Binit has given a wonderful presentation on repowering. That research, I mean, whatever report he presented was more in detail, and it is precisely surveyed and given the input. And thank you, CSC, for giving us this opportunity for which is the need of the hour. So I would like to cover my session. I have not prepared any PPT and all to present it, but I can. I would like to cover this thing like in 3 areas. First of all, why repowering? Yeah, why it is repowering? What is the objective of repowering? And what is the challenges we are facing it? And how we can bridge the gap? So these are the 3 areas I am going to cover. So why repowering? Repowering is for, first of all, this our government of India has the ambitious target of, having renewable energy target of 500 gigawatt by 2030, out of which so far, only 100 gigawatt we have reached, in which 60 gigawatt is from solar and 41 gigawatt is from wind. So out of this 500 gigawatt, 140 gigawatt is from wind. Out of this 140, 30 gigawatt is offshore. So 140 minus that is 110, and 110 gigawatt minus existing 41 gigawatt, which is already commissioned. So 70 gigawatt is the remaining one. 110 gigawatt minus 40 gigawatt, 41 gigawatt already commissioned. So 70 gigawatt is the remaining capacity to be added by 2030. That means per year about 10 gigawatt in next 7 years. So in 7 years of time, each year 10 gigawatt we got to add to meet out that target set by. So what is the way forward to increase the capacity to this 140 gigawatt of wind? So one option available immediately for the government of India is the repowering. So this is the background of why the repowering came into picture, to meet out the target set for wind. So the objective of repowering is to promote optimum utilization of the wind potential, wind energy resources. So this is what the objective. See, there is a report which says about 36 thousands of turbines installed in India, among which 18% of the turbines are below 1 megawatt turbines, which is coming about 18% of 36. This thing is about 6,000 turbines, out of which only Tamil Nadu, it is having about the capacity of 4,000 megawatt, about 400 turbines or 500 turbines. So that actual number has to be counted. So this much potential, and we saw that Mr. Binit, when he has presented the numbers, we saw only from the RLY Mulli side about 800 megawatt repowering and 3,000 turbines or somewhat was there. See, that was the thing. So objective is to promote optimum utilization of the wind energy. And second, I would like to cover as I mentioned, out of 36,000 turbines installed in India, 18% of those turbines are less than 1 megawatt. And total capacity in India is about 10.5 gigawatt, are having 15 years old operations turbines. So we have in India, so that to meet out the target set by government of India, 10.5 gigawatt across India is available to immediately repower it and bridge the gap. So secondly, what is the benefit of repowering? So there is a technical benefit. What is technical benefit? It is nothing but, when you remove these oldest turbines with the lower capacity, putting the larger turbines, the increase in generation. So there is a technical benefit, and because of the technical benefit, there is a financial benefit also, right? So the revenue increases. And social benefit. What is social benefit? See, local jobs, local employment, many local employments we get. And the last one is environmental benefit. What is the environmental benefit? It reduced mortality of the avian creatures. This, low speed, larger turbines, less risk of aviation creatures. So this is the benefit of having the repowering. First, we saw the objective. Second is the benefit in terms of technical, in terms of financial, and third is social, and last one is environmental benefit. We get all these 4 aspects of benefit in repowering. And the challenges. Since most of the points my co-speaker and Beneath Das presentation has covered, so I would like to directly go with the challenges. Okay, so what are those challenges? So first of all, we have I would say the policy challenges. The MNRE policy 2016, it has specified some, the repowering capacity can be 1.5 times or 2 times, some number is given. If you are replacing the 250 kilowatt turbine, you can go with only 1.5 times of the existing capacity. That means, so you can go for maybe, 1.5 times of 250 kilowatt. So those turbines are not at all available at this moment. In the no manufacturers are manufacturing those turbines.
Right.
So in the policy, yeah.
Yeah, right. Yeah.
Yeah. So in the policy, now I want to, because since you both have covered so many things, I want to just focus on only the challenges. So by mitigating the challenges, the target can be achieved. That is what I want to cover it. So first of all, in the 2016 policy, some number of times of the lower capacity machines you can go for it. Like 1.5 times or 2 times, I got to see it. I think 1.5 times only. If it is a 500 kilowatt, then you can go for 1.5 times of 500 kilowatt. Then it is 750 kilowatt or something, right? But those turbines are right now, it is not available. No manufacturers are manufacturing those turbines. So we have now the standard model of, the lowest model available in the market is 2 megawatt, which is Inox, and followed by Suzlon 2.1, and then Senvion 2.7. All those models. Lowest capacity available in the market as per MNRE RLM is 2 megawatt. 750 kilowatt, yes, there is one manufacturer, Pioneer Windcon, and 250 kilowatt, Siva is available. But since we are talking about the repowering part, so we have a older turbines of below 1 megawatt turbines, which is having the 18% of population of the turbines installed. That is what the survey report says. And second, the apple to apple replacement. If you want to replace the only wind turbine with the wind turbine, then definitely the repowering is not going to be, successful. We should have a hybrid option. I think one of the slides you also covered that. Because now, 25 years ago, the sites which were developed has come up with so many developments, nearby dwelling units and national highways, railway, and lot of multi-story buildings central have come up, because those projects were developed 25 years ago. So all these have come up, and as per MNRE guidelines, we are not supposed to do any projects within the 500 meter that guideline says, right, from the dwelling unit. So looking at all these things, the criteria for repowering and other things. So we should go, the government should allow the hybrid option in the policy. Wherever possible, you use solar also.
Yeah.
So we should meet that RE target. Let it be in the wind farm or solar farm. And we are and India is blessed with a lot of potential for wind and solar, right? So it's second, that hybrid option we got to go for, and third, only solar also the government has to allow. Suppose if a lot of transmission line has crossed in the existing sites, the transport challenges will be there. Those sites we can select for only optimizing with a solar repowering. Those those old turbine can be dismantled, and on that places solar needs per megawatt only 3 acres of land. Even this option can also this option can be also given to the government. Like so I am part of Indian Wind Power Association. I am the treasurer for the Pan India. We have given all these points to MNRE also, but as a team from CAC also one letter should go, so that it should not be apple to apple, only wind to wind. First of all, that number has to be removed from the policy. Whatever the repowering this thing is possible, site specific, customized one, we have to go for it. And second is hybrid. Third, I said only solar also the government should allow. So, yeah. So few other challenges like the Mr. Suryan, Jaikumar Suryan, he has covered that evacuation challenges. So now the turbines are coming up with a 2 megawatt and some turbine and customized with a 33 kV grid only. So since we are now looking at only Tamil Nadu point of view at this moment, Tamil Nadu has 11 kV and 22 kV also. Okay, so this 11 and 22 kV grid augmentation need to be done. 110 kV by 11 kV pooling substation, 110 by 22. This 11 and 22 augmentation, we need to look for it. We have to augment it to 33 kV. That challenge we have. The complete circuit. And Tamil Nadu is not having, Tamil Nadu is having only the 10-1 option, very limited options. That is pooling substation concept. Otherwise, the evacuation or connectivities are permitted directly from the tangent go substations. Right. So this is another big challenge we have it in Tamil Nadu. Because the turbine like Vestas and all, it is having the transformer on the top of the nozzle. And it is customized only to run with the 33 kV. Not only Vestas, some other turbines also. It is all customized to 33 kV. So the transformer rating and the specification changes at the substation level. It's a big, if you want to change the transformer, then again, the lead time for ordering the transformer and upgradation, augmentation of the substation, etc. Everything is there. The downtime will be more. So there has to be some incentives to the repowering, clients, or that has to be made. Okay. So one is land. I always put it this way, land, wind, grid. These are the 3 dimensions of wind energy. All are 4 letters word. Okay. Land, wind, grid. So wind, yes, it is a proven already there. So that lot of potential are there. Wind is already proven. Those are all proven sites. So there is no need to say this, no need to study again, put the wind mast. Only, only that period we can say that wind mast study or wind study. But land and evacuation, yes, land, wind, land and grid, it has challenges. Start from the, aggregation of the challenges suitable for repowering projects. The name, we should find a project who is having the single ownership of multiple turbines, multiple smart turbines. So that, the land aggregation become easy. Yeah. And the second land aggregation part, when you are doing the augmentation of the overhead transmission lines, so then the right of way, because everything you have to convert it to 33 kV, the internal transmission lines. So that also having the huge, these things. And another point of in grid, the augmentation of the substation of the tangent core. Tangent core, even their property of the transformer also getting failed, the investor, the client has to put their money and replace the transformer. The poor treasury of tangent core, it is not financially sound. The tangent core, to say the TNB outstanding is also huge to the investors. So who will, there are upfront cost involved in developing the evacuation. So land, wind, grid, out of which wind, yes, there are sure wind is available, but there is a challenges only in land and grid. And over land and grid, we have a challenges in the policy perspective. Yes. And there are 3 major key stakeholders in the industry. One is IPP, and second is developer, third is OEM. All 3 has to come together and work for the workable solutions on this repowering. It is not only in the developers portfolio, even the OEM and IPP also should focus on this. These 3 are the major key stakeholders of wind energy. ISP become the 4th key stakeholders at this moment. So I want to put up my points only on this area. So what is the objective and the benefit, technical, financial, this environmental and social benefits. And third is what is the challenges. The conclusion, I would say first we need the challenges in, the policy has to be revamped with, giving all these facilities in the framework. To cater these land and grid challenges, basically. Wind, there is no challenges. It is already proven sites. And WTG suitability analysis has to be done by the OEM. That will be done by OEM for sure. Because nowadays, we have only class 3 turbines. Class 3 turbines cannot be put in class 1 sites. But that OEM will take care of having this MCA like machine MLA, machine load analysis or whatever it is, that OEM will take care. So OEM, IPP and developer, together we have to come to make this repowering policy a success. And this is the need of the hour. And to meet the government of India target that 500 gigawatt, out of which 140 gigawatt is wind, out of 140, 30 is from offshore. So 110 we have. 110, in 110 we have already completed only 41 gigawatt.
Thank you.
So remaining 70 gigawatt we have, that has to be made in 7 years of time. So per year 10 gigawatt. So repowering capacity available in India so far is about 10.5 gigawatt. Okay, so 10.5 gigawatt capacity across India is available, which is which are about 18% of 36,000 number of turbines erected in India. So with these numbers, with this input, so we need to put up to MNRE for first correcting the policies. I mean, there has to be flexible options, not only wind to wind, apple to apple change. And there has to be a combination of wind and solar, and only wind, solar also possible some places, they got to allow.
Thank you so much, sir.
Yeah, thank you.
For sharing with us such detailed insights on wind repowering. We have just some few questions. I think we have already overshot the time, but we do have some few questions which is in the context. So I would like to ask you those questions. That, sir, you are the National Council member as well as the treasurer in Indian Wind Power Association. So based on the members of the association and the working of the association, we would like to know that if they are coming for repowering, and what is their stance on behalf of the association? If you can.
Thank you. Yes, I'm in this Indian Wind Power Association almost 12 years active member. See, we put all these points, whatever I have discussed here. The policy should have some flexibility, like because many of the states tried adopting or implementing these policies, but it is not given the fruitful result in any states because there is a question mark of what about the PPA continuity. So there is policies, it is calm about that. I mean, nothing is mentioned about the PPA continuity, and now the reverse bidding action is going on, reverse action in process. So now the average APPC by SECI is about below 3 rupees, but the older turbines, most of the turbines are having above 3 rupees also. So then what will be the PPA rate? So that and all, it is silent about it. So first we need the correction in the policies. So first of all, the PPA, the investor, the repowering, whoever has decided to go for the repowering. So I mean to say the full repowering is not happening, only partial repowering is happening.
Right.
Yeah. So for the full repowering, we should have a clarity in the policy. As I mentioned, the land acquisition and the grid area, it needs a lot of, and the third one is policy.
Okay.
As I mentioned, there is a flexibility, hybrid they got to allow, and also only solar if it is possible, because the 25 years development, and MNR is only saying that 500 meter you should not that you have to maintain the distance 500 meter from the wind turbine, no dwelling unit. So it is not possible at all. A lot of national highways, a lot of buildings, a lot of railways have come up. So that and all is impacting this RE. So in that areas, at least the policy should allow at least to develop solar or both hybrid.
Okay, sir. One more, just a small question, which we wanted to ask, like, how many members from the association would be interested in migrating to repowering?
See, in Tamil Nadu, since we are very particular about Tamil Nadu today, today's our discussion is, see, in Tamil Nadu, 70% of the customers are captive or retail customers. More than 70, it could be 80 also. Everybody is having 2-3 turbines. So there we are having the problem of, the land aggregation. We could see only few, captive users having 10 numbers of turbines in single place. Maximum number is 10 numbers. And that adding capacity to 5 megawatt or 7.5 megawatt, which we can replace it with, 7 megawatt needs 2 turbines, 3.5 megawatt or 3.3, the ladder size, or 3 into 2.7. But we will not able to put 3 numbers because of these micro siting guidelines. Again, that is also by MNRE. 3D, 4D, 5D, 7D. I mean, state to state, it differs. So there also the government has to give some flexibility of, having only the terms of park efficiency. And we have a lot of scientific tools available today to, address, work on the WRA perspective. So if the park efficiency is more than 95%, then there should not be 3D, 4D, 5D concern. Then we can go for 3 machines in this 10 megawatt land area. Otherwise, I go to see the neighboring turbine also. The guideline says you go to maintain, if mine is 2.7 megawatt turbine, the 130 is the rotor dia. Okay, then if I go to maintain, then according to my turbine, I go to maintain the 3D. Okay, it is not with the neighboring turbine. Neighboring turbine could be a 30-meter rotor dia. So I got to give as per my turbine specification. From that turbine to my 4D will be 520 meter. So only, I can plan for 3 numbers of 2.7, but where practically it is possible only 1 turbine. Okay. So the investors are not showing, because why I have to, dispose 7 megawatt and go for 3 megawatt.
Sorry to interfere. This intercropping, even that is being now evaluated, when it's said in Mantasode. Intercropping means existing smaller dia as it is, keep bigger dia nearby. So you compensate the height of the wind force and balance the efficiency of the turbine. So that study is also going on in Europe. So I think with that, this whatever the diameter from some turbines we can leave, maybe the efficiency will go a little down for the smaller capacities. It could be okay. But still, the overall capacity of the substation, we cannot exceed. Ultimately, whatever you do, powering, repowering, we cannot exceed the existing substation, which we need to keep in mind. The only possibility, as you rightly said, is the hybrid and local consumer, create the local demand. So maximize the power from 1.5 to 2 times from the substation and utilize there itself, so that your repowering would benefit the triangular war between the investor, utility, and the government policies.
Yeah. See, now this project cost has gone up like anything because of the power rate. I mean, so that the reselling business is very good at this moment.
Yeah.
People are looking for the old assets.
And next point is the power trading. So the power trading, whatever the tariff the government gives, they need to make easy of the third-party sales and the power trading, which this is what I told you. The government should make a platform where the power trading can happen easily for the investors and the generators, so that for sure this will give a confidence.
See that, first of all, that number has to be removed from the policy, 2.5 times or 2 times. Only, the repowering can be, it could be some numbers has been given.
So everything is in draft, so nothing is in order. Okay. So still we are fighting for the government order. So let us keep pushing.
MNRE, we have to represent MNRE.
Yeah.
With this only the addition can happen.
Yeah. With that, we have got a couple of questions. I'll ask both of you, Mr. Jayakumaran and Karunamurthy sir, to just quickly give a 1-word or 2-word answer about those questions. Like the government of Tamil Nadu has recently announced its recent budget, that they will come up with their new policy and the preparedness in repowering, and they will come up with their special purpose vehicle, particularly for wind repowering aspect, to continue with the repowering policies. So why do you think the government should support the developers in your stance? Like what are the areas in a 1 or 2 words?
See, first of all, the point is tariff. Okay. Whatever the policy you draft, the benefit is the commercial benefit for the investors. And how long term that tariff is you are going to sustain with additional benefits, and making the taxes and other banking sectors easy for them to mobilize this power trading. So if that is clear, so the main point is tariff and the long-term benefit of the tariff PPA. If that gives some escalation matrix, like O&M, what you see is every 2 years you put a escalation, like 5% of wear and tear against. The
True.
same way for the generators on the repowering, because we are in need of power. So that escalation we not put 5 years, at least 5 years would be better, at least 10 years that the PPA should have a escalation matrix. So that will definitely bring the motivation for the investors.
Okay. Okay. Yeah, Mr. Karunamurthy, sir.
No, I agree with what Mr. Jaykumar has told. Yes.
Okay. Yeah.
Yeah.
So the
So-
answer would be the same.
Tariff.
Yeah. So another questions that we got from our ex Deputy General of NIVE, Mr. Gomati Nayagam. He asked about a land pricing issues. So I'll just scroll the question. Yeah. So in fragmented ownership, we have said that around 20 years old projects were there, and in these 20 years there was a land appreciations. So there is more or less there was a more than the asset value. The appreciated price has gone up, and it is far like higher than the asset values. So how to compensate that? How can the developer or government should think on those areas?
I'll tell you, like on this minute, like initially, 1 or 2 decades ago, the BOP cost, balance of plant cost, okay, it was hardly 50 lakhs per megawatt. Okay, now it is 1.5 crores to 2 crores. It varies from state to state. So that appreciation of the not only the land, the materials of the BOP, steel and the poles and transformers, all these BOP items has got appreciation. So you need to mind both in consideration of the balance of plant cost. For sure, yes, definitely that will increase for sure, wherein it has to be compensated by the tariff. Again, the point is you need to compensate whatever the generation loss which we are putting on the 2-year repowering, formation of projects. You need to be compensated with benefits by the government. So that state government need to consider the loss for short term, give more benefit on the long term, so that this small increase in the land cost will definitely go off. That will not be a problem.
Correct. Yeah.
My point is, the ownership remains with the owner of the wind turbine only,
Sorry. Yeah.
See, who wants to do the repowering? The owner of the wind turbine.
Yeah.
And the land ownership is with the owner of the wind turbine only. Correct? Where the developer is going to have the problem.
So what is saying, when you convert from 250 to, for example, 500, you need more land, and with respect to 5D70,
5D70. Yeah.
when he wants to get that additional land, that will be for sure there's some cost. Yes.
If anybody is having single machine, he cannot think for repowering only.
Exactly, that's what I said. So it has to be different
So he can
combination
go
of
for only
repowering.
because many things are happening in Tamil Nadu. With this 250 and 500, they are going for single machine. I mean, all the 250, 25 years old, whoever has disposed this machine, they are going with only 250 kilowatt.
And
that
for
is
sure,
not repowering happening.
Yeah, for sure. What you said is right. And what would happen is 10 to 20% people will return back the power, the load, they will serve the load back to the government. So that can be taken benefit by the other investors. So it has to make a lot of combinations.
So that is what the group, we have to make a group consortium,
Yeah.
what you mentioned in your presentation. We have to make a consortium and so there has to be, we have to form a group and do this repowering things.
And fixed milestone, yes, the government order will be released on this date and we need to do backward working. If we keep discussing, even in 2025, we will keep discussing repowering, it will not be on ground.
I think Mr. Karunamurthy's IWPA can formulate such kind of a group and come up with a exercise that how this developer, like this wind manufacturers or the generation companies can come up with a consolidated plan and to come up with a repowering capacity exercise.
See, we are already working.
You are right. He has got a trump card. You can use.
That's what
I don't know. I'm
his
very passionate
question
about
was
this.
like, what was his preparedness in terms of as a founding member or the treasurer is concerned. So I was even curious to know about more about your interest in wind repowering.
No, we are very much interested. In fact, in WinPlus, we have a, I think I have not presented because there was a last time I have not presented anything. So in WinPlus, we have a, we have explained. If you have a time, I can present it the one slide only.
Okay.
Is it okay? Otherwise, okay, I will just verbally, I will verbally explain it.
Okay.
See, there are 6 stages involved in developing, constructing, and delivering the projects. The stage 1 is WRA and permits. Stage 2, land and ROW. Okay. Stage 3, then pooling substation, external transmission line. Stage 4, then civil foundation, internal transmission line, and then a road, SCADA, unit substation, etc. Once these stage 4 are, 1, 2, 3, 4 are ready, then the stage 5, that is installation of the turbine. Stage 6 is the, wind up, post installation commissioning, it is a wind up. So there are 6 stages involved in developing, constructing, and delivering the projects, right? That is what I always keep that land, wind, grid. And another 336 like land, wind, grid, and OEM, IPP developer, and 6 stages. This is all about wind business.
Yeah.
Okay, so we have to give this knowledge to the the existing owners. Only with the group only the repowering will be possible, and their revenue is definitely going to increase by being the part of that member of that group.
Correct.
So we right now from the association, Indian Wind Power Association, there are 8 owners. Okay, so with them we have discussed, and we are moving ahead with this direction already to make a group, and then approach MNRE for some policy, revamping the policies, having the flexibility in choosing the RE component, whether it is wind, solar, or hybrid, or standalone wind or standalone solar. Everything is, we want some flexibility in it.
Okay.
We are already, association already we are working on it, making the group of some 10 megawatt project. We want to do it like practically in Tamil Nadu. Yes.
Yeah. So there is always a strength there is always a strength in unity. So we all know. I think someone raised hand, Maitri.
No, I don't think so.
Miss Roshmi Sen, can we allow anyway?
No. Where is it?
Am I audible?
Yes.
Yeah, you are audible.
Yes, sir. Wonderful presentation. I am a faculty member at NIT Rourkela in the Department of Architecture and Planning. So we have to deal with a lot of issues because our subject is very interdisciplinary, and right now we are only teaching undergraduate students. So this is Orissa and there is a coastal area. So when a student in his or her undergraduate thesis is planning for a high-rise building with a wind power, so as you said, I came to know many things, many terms which I will search, because we are not really energy specialists, but we have to do green buildings, lot of things. We have to do art as well. So we would like to know that if you want a wind energy and a student is designing a cutout in a building, that has happened in many developed countries, in Singapore, where they want some wind power to come. So how do you think it could be related? Like if there is land and if there is a appropriate site, how the grid interaction can take place from, say, we are starting from zero?
Roshmi, I'll just give a brief on this. Like the volume of the building, first you need to tell. Okay, if it is a multi-story, what you say is possible. If it is a single or double story, you can go for solar. Okay, you need not to go for wind.
Yeah.
And if it is a multi-story, you have 2 options. One is the horizontal axis turbine and the vertical axis. The horizontal axis will have the problem of vibration in coming years, which will create structural instability even in your building. Whereas that vertical axis has got a technical problem of controlling the power. So you need to make a hybrid concept of the vertical axis and the solar. which could make your consumption compensated by at least 50%, not 100%.
Okay, thank you very much.
Thank you for answering the question, Jayakumaranji. Thank you.
Okay.
I think we'll wind up right now. So first of all, let me extend a big round of thanks to our expert panel members, Mr. Jayakumaran and Mr. Karunamurthy, for such a wonderful and insightful session and giving us all the details regarding repowering. Thank you, Beneath, for sharing an insightful presentation as well. The wind turbine generator technology has evolved over, and individual rated capacities of the wind turbines have increased from sub-megawatt to multi-megawatt scale. Most of the wind turbines installed in India up to the year 2000 are of sub-megawatt capacity and are at sites having high wind energy potential. Some of the old wind turbines have already completed their design life, while some are approaching the end of their design life. These wind turbines are not only inefficient in comparison to the latest technology, but also have lower hub heights in comparison to the hub heights of 120 to 140 meter range being installed these days. The lower hub height wind turbines are not able to harness the higher wind speeds available at higher hub heights. Therefore, it is essential to repower these older, smaller wind turbines with high capacity and higher efficient turbines in order to optimally utilize the wind energy resource available at the respective sites. These discussions were quite helpful, and they gave us a view on the technical financial benefits of repowering as well as the challenges of the policy of 2016. We also got to know some quick facts about hybrid technology and forming a consortium in order to move ahead with repowering in India. So I would like to thank all of you on behalf of CSC for taking out time from your schedule, being here and sharing with us your knowledge of the sector. Thank you. Have a great day.
Thank you for CSC doing a great job for the next generation. Keep doing it. Thank you so much.
Thank you.
We are there with you. We are there with you all the time.
Sure.
Thank you, sir.
Thank you.
Thank
so
you.
much.
Thank you. Thank you, sir.
Thank you, Karna, sir. Thank you.
Right, sir. Bye.
Bye.